Today we're going to be talking about vectors. And vectors are an array that has a specific length. So I think of 50 miles per hour in a northwest direction. Okay, so it has a magnitude, it has a length, and it has a direction. I also equate this to like airplanes. Airplanes go in a direction, they have a magnitude or a length that they fly, and they fly in a certain direction. So to find the direction of vector AB, and that's how we write vector AB with a little arrow over the top, change in x over change in y. Now let's look at it like this. If vector A was point x1, y1, and vector B, I'm sorry, point B, these are both points, I apologize. These are both points, guys. x2, y2. To find the length of vector AB, what you would do is you would take x2 minus x1, y2 minus y1. And it has to go in that order. Now, a lot of times we call that component A. Sometimes, a lot of times we call that component B. To find the magnitude or the length of that vector, we have the square root of a squared plus b squared. So let's do an example so you guys can see how this applies. So points A and B are given. Find the length of vector AB, or find vector AB, I should say, and find the magnitude. So point A is -3, 4. Point B is 1, 2, 3, 4, 5, 6, 7, -2. I'm trying to find basically what is that vector. Okay, so to find vector AB, you take your x component, since B is listed second, you do 7 minus a -3, which is 10, -2 minus 4, which is a -6. Now look at this vector like this. In your x direction, to get from A to B, do you go 10 in the positive x direction? We go 10 in the positive x direction. Do we go down 6? We go down 6 in the y direction. So that's my x direction, that's my y direction, or my A and my B. To find the magnitude of AB now, all it is the Pythagorean theorem. If you draw in this triangle, this was 6, this was 10, so we have 10 squared plus 6 squared, we get the square root of 136. Let's give that to me in simplest radical form so I can factor out a 2 and I'm left with 34. Multiplying a scalar is multiplying a vector by a constant. So we have some vector, for some reason we always like v. If I want to do 3v, basically I'm going to take this vector v, I'm going to clone that guy, so same length, same direction, but I'm going to clone it 3 times. I'm going to copy it 3 times. Same length, same direction. Now this vector is now the length of 3v. Addition of vectors. Okay, look at this like legs of an airplane flight. So you have vector v that takes you one direction. Then you have to switch planes, and you have vector w, which takes you a different direction. And we call this tip to tail because you start with the tail, the tip of the vector, and then you match up the tail of the last one to the tip of the one before. And what's your resulting vector? Your resulting vector is the final leg of your trip, w plus v. Okay, so that's your resulting. Negative vector. Vector W, negative W is the same length, just you switch directions. Draw the following vectors. Now, when you're drawing vectors, you can draw them anywhere in the plane. So I know I go positive 8, but negative 6. So make sure you have enough space in your plane. So I go positive 8, negative 6. What was that? 1, 2. So that, if I'm going to call that vector v, say, this is going to be half of v. So just to show you guys, I'm going to start it down here. So I'm going to go, half of v would be 4, negative 3. So I'm going to go over 4, 2, 3, 4, down 3, 1, 2, 3. This is half of v. Now if I take this whole vector, I bring it back over here, notice how 1, 2 of those fit onto v. So I know that it is half of v. Find the vector sum, then illustrate the vector sum. Okay, this is actually really easy. Vectors are actually not too bad for what we do in geometry. Add the x components. When I add those x components, I get a 4. Add the y components, we get 8. So I have a positive 4 direction and a positive 8 direction. What I'm going to do is I'm first going to draw this first vector here, and I'm going to call that v. So I'm going to start this vector over here. I'm going to go 3 in the negative direction. 1, 2, 3, up 2. So that's my vector v. Then we have our vector w that is positive 7 in the x. 1, 2, 3, 4, 5, 6, 7. Positive 6 in the y. 1, 2, 3, 4, 5, 6. So that's vector w. Now your resulting vector should be from the tail of the first one to the tip of the last one. That's v plus w. And that vector should be 4 in the positive x direction, 8 in the positive y direction. Let's make sure. 1, 2, 3, 4 in the positive x. 1, 2, 3, 4, 5, 6, 7, 8 in the y, so that works out. So I had 4 and 8, which worked out with the math that we did above. Okay, there are your lesson questions. Please make sure your lesson summary is submitted on time.